Assalamu alaikum. Welcome back to Sterling Learning, where education gets meaning. My name is Electrical Telecom Engineer Zubair Rasheed, and this is the series of Physics 10th Numericals, chapter number 18, which is the last chapter of Physics 10th. Numericals are in this chapter are of basic nature, only the half-lives are discussed, so we will try to finish it as quick as possible. The chapter number 18 name is the atomic and nuclear physics formulas. There were no formulas for the sake whatever, but only one half-life relation was there. So I had written few lines about atomic and nuclear physics. The atomic and nuclear physics are two branches working side by side. Atomic physics studies the atomic structure with the focus of its motion and other physics related aspects. The nuclear physics studies the radioactive elements like uranium and which is used in preparation of atomic bombs as well as used in the atomic power plants in Pakistan as well and in other countries. Radio elements and their transitions and the transition times given as half-life duration. Then half-life is the time in which the element remains the half of the started quantity. For example, 10 uranium atoms after one half-life will 5 will be remained. क्या मतलब कि एटॉमिक और थ्योरी न्यूक्लियर फिजिक्स जो हैं ये दोनों साथ साथ काम करती हैं. एटॉमिक थ्योरी जो है वो एटम के अंदर स्ट्रक्चर को जो उसका जो अंदर उसकी खासियत है फिज़िक्स के लिहाज से उसका मुताला करती है. और जो न्यूक्लियर फिज़िक्स है उसमें जो रेडियो एक्टिव जिसे तापकार एलिमेंट कहते हैं, तापकार अनासर कहते हैं, उनकी जो तापकारी और उनके तापकारी के बाद जो उनके अंदर जो तब्दीलियाँ आती हैं उनके बारे में पढ़ते हैं हम. हाफ लाइफ क्या होती है? वो टाइम जिसमें एलिमेंट जो जितनी तादाद शुरू से हुआ है उतनी उसकी आधी रह जाए. जैसे कि 10 यूरेनियम एटम उसको एक हाफ लाइफ के बाद वो 5 रह जाएं, इसको कहते हैं हाफ लाइफ. एटीन पॉइंट वन है. इसको क्या कह रहा है जी? व्हाट इज द डिफरेंस बिटवीन half life of nitrogen 16 and 16 and 7 is 7.3 seconds. Half life. A sample of nuclide of nitrogen is observed for 29.2 seconds. Calculate the nitrogen of original isotope remaining after this time. We have observed it at 29.2 seconds total time. Half-life we have already discussed, in which the element remains half. So total time is 29.2 seconds. Single time is 7.3 seconds. We will calculate the number of half-lives. How we would calculate? Total time divided by half-life 7.3 seconds. The result comes out to be as 4 half-lives. So first half-life 1/2 remains. Second half-life 1/2 to 1/4. Third half-life 1/4 into 2 equal to 1/8. Fourth half-life 1/8 into 2 is equal to 1/16. So 1/8 16th of the original remains. In the same way, the rest of the questions would be solved. Cobalt 60 is a radioactive element with half-life of 5.25 years. Cobalt 60 half-life is given as 5.25 years. What will remain after 26 years? So number of half-lives 26 over 5.25 equals to 4.95, which is approximately equal to 5. So same as above, first half-life, second half-life, third half-life. Sorry, we will make it like a table. Half-life and remaining. First half-life 1/2, second half-life 1/4, third half-life 1/8, fourth half-life 1/16, and fifth half-life 1/32. (18.3) Carbon 14 has half-life. Carbon 14 half-life 5730 years. Time to reach 1/8 of original. So half-life remaining, half-life 1 remaining 1/2, half-life 2 remaining 1/4, half-life 3 remaining 1/8. So 3 half-lives equal to 5730 into 3 equal to 300, 3 3s are 9, 3 7s are 21, 3 5s are 15, and 2 17. So it will become 1.72 into 10 power 4 years. 18.4 Technetium 99 M is radioactive and is used to diagnose brain. The element has a half-life of 6 hours. Half-life is 6 hours. Quantity in start is 200 mg. What will remain after 36 hours? Number of half-lives. 36 over 6 is equal to 6 half-lives. So same as above, remaining and half-life 1 200 by 200, 200 by 2 is equal to 50, 3 50 by 2 25, 4 25 by 2 12.5, 5 12.5 by 2 6.25, 6 6.25 by 2 3.12. So 3.12 mg remains. (18.5) is half-life of radioactive element is 10 minutes with initial count rate is 368 counts. Half-life is 10 minutes. Count rate is 368 initial. Per minute. Find the time by which count rates reaches. Count rate reaches 23 counts. Half-life remain 10 minutes. 368 by 2 4 3 1 6 no, 184 184 20 minutes. 184 by 2 92 30 minutes. 92 by 2 46 40 minutes. 46 by 2 is equal to 23. So after 40 minutes The count is 23. 18.6. In an experiment to measure the half-life of a radioactive element, the following results were obtained. Count rate, time. 400 at 0, 200 at 2, 100 at 4, 50 at 6, and 25 at 8. So graph would be drawn like this, time, count rate. 0 count is 400, 100, 200, 100, 50, 25. 200, 100, 50, 25. 2, 4, 6, 8. 0, 2, 4, 6, 8. At 0 it is 400. Starts from here. At 2 it's 200. At 4 it's 100. At 6 it's 50. At 8 it's 25. So graph becomes like this. So how much remains? 1 by 2 after 2 minutes. 1 by 2 remains after 2 minutes. So half-life is 2 minutes. (18.7) A sample of certain radioactive element has a half-life of 1500 if it has an activity of 30 through 100,000 counts per hour at present time. Then plot a graph of the activity of this sample over the period in which it will reduce to 1/16 of its present value. Half-life is equal to 1500 years, and count rate is 32,000 per hour. So when it will reduce to 1/16. For that we will draw the graph here. Time 1, 2, 3, 4, 5. 1 half-life. 2 half-life. 3, 4, 5 half-life. 32,000 half of this and half of this and half of this. Turn the here, 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 and here. The graph becomes like this. 1 by 2, 1 by 4, 1 by 8, 1 by 16 and 1 by 32 is this, and 5 half-lives. 5 half-lives means 1500 year into 5, 500 years. Okay, half-life of radioactivity is found to 4,000 years. The count rate per minute for 8 successive hours were found to be 270, 280, 300, 310, 250, 85. Half-life is equal to 4,000 years. The count rate for 8 successive hours. One, 2, 3, 4, 5, 6, 7, 8 hours. 1, 2, 3, 4, 5, 6, 7, 8, and the count rates are, I want this, 270, 280, 300, 310, 285, 290, 305 and 312. Variation in count rate shows random. It is not, variation in count rate shows random nature, and it is not exponential. Because of difference in half-life, and sample time. Huge difference. Ashes from a campfire deep in a cave shows carbon-14 activity. Only 1/8 of the activity fresh wood. How long ago was that campfire made? 18.9, the last one, and the battery, my camera is almost ending. Shows carbon-14 activity 1/8 carbon 14 means 3 half lives. First half life 1/2, second half life 1/4, third half life 1/8. So in 1 half life of carbon 14, time is 57, 30 years. So campfire is old. 57, 57 30 into 3, so 17190 years old. That's the end of the numericals. And if you like the numericals and my method, then please like it, comment on it, and subscribe to my channel. And please share it with your friends who are looking for some guidance regarding the numericals of physics. It is the physics 10th numericals, but I will soon upload all other physics like ninth, first year, second year physics numericals no, lectures, and the theory lectures as well. So it is the last lecture of the numericals, and with the best wishes and praise for you, and with the hope that you will pray for me as well. uh, I leave you in good health,